Welcome back to the shop and to the channel. In a previous video, I spent some time disassembling this Brown & Sharpe universal dividing head. It was caked full of old grease, and I think that's a bit of an understatement. The hardest part by far was getting the spindle out for a couple of reasons. One was the nut that's on the back of the spindle was on really tight, and I had to make a tool to get it off twice. And I was just a little bit nervous about knocking out the spindle out of this thing, worried that I could end up doing some damage that would be unrepairable. But I managed to get everything apart without doing any real damage, any damage at all, really. And whilst you were sleeping, went ahead and got all of these parts at least reasonably cleaned up. I opted to not disassemble the spindle, mostly again out of fear of doing damage to the bearings. And once everything was degreased, the bearings felt great and I didn't see any reason to risk it. I did put the small parts into a heated ultrasonic cleaner with some degreaser, and it got rid of 99% of the gunk. So I'm at that point now where I can start some reassembly. Step one in the reassembly is to get the dividing head remounted to the base. I did use some stones and anything else that I felt was necessary to ensure that there were no burrs on any of these dovetails, either on the base or on the dividing head. This thing is a little bit heavy, not so much when it's empty, but it does take a little bit of finesse to get it to fit down in those dovetails. Once I get this slid in, I'm going to reinstall the clamps that lock it in place. I think removing them early when I was taking this thing apart was I wouldn't say a mistake, but it certainly created some trouble for me that I didn't need. Well, reassembly is just disassembly in reverse. And I'm actually referring to my disassembly video so I can remember exactly how this thing came apart and what parts go where. I didn't capture everything because, like I mentioned, there was some stuff that was just hidden by grease. But this eccentric shaft is what's used to disengage the worm drive from the spindle so the spindle will rotate freely. And this is that thrust washer that I couldn't see when I took it apart. It was actually stuck in the inside of the casting until I started cleaning out all the gunk in the parts washer. It goes on first and then there's a geared nut that goes on after it. Well, I think this is kind of a neat little bit of engineering. This nut is driven by a pinion shaft that goes through the right side of the dividing head. And if I disengage the worm drive from the spindle and I want to make sure it doesn't re-engage, or vice versa, I spin a knob on the end of that shaft, which will loosen or tighten this nut from the inside. There's a thrust bearing that sits on the end of the shaft, and it is pinned in place. I'm just putting some grease on it here just to make sure it stays there while I am reassembling everything. Next goes on is this counter shaft and an idler gear. This is for engaging the dividing plates. Now, one thing to note that I didn't realize when I was putting this together is that it needs to be oriented in a very specific way. And with the way that this is going in right now is wrong. I did discover this, but not until this thing was almost completely assembled. I was able to adjust it without disassembling it, but yeah, that grease or lubrication port at the top there needs to be facing a different direction in order for some other mechanisms to operate correctly. And well, lesson learned. Thankfully, I didn't have to take it apart to fix it. Well, that shaft is held in place with a nut from the inside of the casting, and this is really my last chance of being able to access it. So I didn't want it coming off unintentionally, so a little bit of blue Loctite on the threads hopefully will prevent that. And I did not remove this rear bearing, same as I didn't remove the front bearing. But while I can get to it now, I'm going to put some general purpose grease down in here. I'm going to try to pack this bearing at least a little bit, not completely full, but I do want to get some lubrication in there. I know that there are some versions of this dividing head that strictly use oil. This one looks like it was designed to use grease. And, for as much use as this tool will get, I think I'm okay with just using grease. I've learned how to take this thing apart. And I suppose if I have to clean out these bearings, I can. But I know it's going to be a little bit controversial for some to use grease instead of oil. But this thing had Zerks all over it, and the side of it said use a grease. So I'm going to use a grease. I'm not exactly sure of every purpose that this ring is for, and this was, again, something that I discovered late in the disassembly. But one purpose it does have is for the spindle lock. There's this little brass shoe that fits into a keyed slot here on one side of this ring. And I think this is kind of like a bearing retainer from the inside. Maybe it's there to hold in some of this grease. But on the one side is the stop, and on the other side is this pin, which is just used to hold it in place, I presume. The handle for the spindle lock screws into the side of the ring, so I need to kind of position this thing in the right orientation so I can get it threaded in there. And now I can slide that pin in on the opposite end through the side of the casting and into that ring. Well, the next thing I want to install is this indexing plunger. And again, this is used if you want to do some indexing on simple 15-degree increments. It doesn't require the use of any dividing plates. You just use this plunger and the faceplate on the front of the spindle. Now, I did have some issues here. It did not want to go in, and I'm not sure what seems to be the issue, but I need to spend a little bit of time trying to figure out what the problem is. The last thing that I want to do with any of these precision tools is start hammering on things unnecessarily. And there's a reason why this isn't going in. I just haven't figured it out yet. I do suspect it's some kind of a burr, although I'm not really sure how I would have raised a burr in the disassembly. Maybe it was there, and that's why it was so difficult to remove this plunger. I'm not really sure, but these fine stones should be able to clear that up. Well, I'm also having a little bit of an issue getting the pinion shaft into the side hole here, and although it's not nearly as stiff, it does feel like, again, there's some kind of a burr on the inside, maybe where these two passages meet. Well, I'm finally able to get this plunger started, but then it starts to get stuck, and it gets stuck to the point where I can't pull it out by hand. So now I need to resort to, using some vice grips to get this off, but I'm starting to get a little worried that I'm going to do some damage to the plunger, and of course if I do that, that could affect its precision, and of course that then degrades the accuracy of this tool. So I'm trying to be really super careful here. I have a hard time believing that it's the plunger. I've got a file here, and it's just gliding over. This thing's as hard as a coffin nail. These rack teeth, I thought maybe there'd be a burr on it, but it's not that. Well, I seem to get it in a little bit further each time, but it's getting stuck, and it shouldn't get stuck at all. It should be a nice, easy sliding fit. I get it to a certain point, and then it stops. So there's something else going on here, and I just haven't figured it out yet. I'll insert the pinion here just to see if that makes any kind of difference at all. Once I get the teeth kind of lined up between the pinion and the plunger, and I don't know that that's really helping me. I was able to get it lined up, but man, it just feels really stiff. I thought if I engaged the pinion here with the rack that would free it up and it would resolve itself, but it's barely moving enough, so there's still definitely something going on. Well, maybe it's something down inside this bore. Using a screwdriver here just to see if I can feel anything, and I can't. I've got some sandpaper here on the end of a die grinder. See if polishing the inside of the bore will make a difference. And that seemed to smooth it out a bit, but it still did not have the desired effect. A while ago, this company DXZ Toes, I don't know how you pronounce this. Anyway, they contacted me and said, "Hey, we've got these bore scopes, and if you'd be interested in trying one out." And I said, "Sure." I had a project coming up I thought it was going to be useful for, but I didn't end up doing that project, and this thing has sat on the shelf for quite a while. But I think this might be a use case for something like this. At least I'm going to give it a try. When I'm restoring these machines and these tools, sometimes I've often thought it'd be useful to have a bore scope so I could look inside of gearboxes. And, when I'm working on the Jeep, these are certainly very good to have. And this one right here has an articulating end on it, so you can move it around, and you can record with it too. So if there's something you want to keep a record of, or even view it later on a computer screen, so maybe it's a little bit larger, this certainly is a pretty decent tool for doing that kind of thing. I am hoping that the borescope might show what it is that might be holding up things on the inside. And although I'm not convinced that what I'm seeing here is definitely the issue, but there is a lot of crap down inside this bore, and it certainly could be contributing to it. I can't say for sure just how much all this gunk back here is contributing to my issues of being able to get this plunger in this bore, but I can't leave it dirty like this, so I'll use the end of a screwdriver here to try to scrape out the bulk of whatever it is that's back in here. Well, better, but not good enough. Well, it's considerably better than it was before. I'm pretty happy about that. Now, I don't know whether or not this is what was causing my issues before, but at least it won't be an issue at this point. Well, unfortunately, that did not solve the problem. I'm still not able to get that plunger all the way in, so I need to think about what I can try next. I took a blue Sharpie and colored this plunger here. Hopefully, by inserting this now into this bore, I might be able to see just where I'm getting some rubbing, and hopefully that will lead to a solution. Where this thing kind of stops, you can see there's some definite marks there near about a 3/4 of an inch from the face of the plunger, mostly on the top side. So let me try restoning the inside of that bore. I'm able to get it in just a little bit further, and if I put the handle inside the pinion here and put a little bit of gronk on it, not too much, I can get it to slide in even more. So that kind of tells me maybe there is a burr on the front of that bore, and I just can't detect it. try using a bit of a coarser stone here, see if I can't use it a little more effectively. Maybe that burr is a little bit too much for that fine stone I had been using. Well, that is a huge improvement. It's still a bit tight, so I want to finish this off a little bit more, but yeah, that was worth the effort to get this to operate smoothly. A little bit more fine tuning on it, and I should be good to go. Put a little lubrication here on this rack. I should be able to get this plunger and the handle inserted for the last time. I do want to make sure that when the handle goes in, that it is lined up correctly. There is a small little divot in the side of this pinion handle that's supposed to line up with a spring-loaded plunger that's mounted to the front. Although I don't know really how effective it is, but with the plunger all the way flush, I want to get that detent so it is to the front of the dividing head where the plunger will go. This set screw captures the pinion shaft, keeping it from being able to be pulled out from the dividing head. Then this little plunger goes in next, followed by a spring, and then all that is captured with a screw. And I don't really feel that detent, so again, I'm not sure really how effective it is. I suppose I could take it out and machine it deeper, but I don't know. It's not worth it, I don't think. Well, this is the worm drive for the spindle, and it can go in now. It slides through the eccentric, that cam eccentric shaft, and that cam needs to be in a certain spot. Otherwise, this worm won't go through the hole. Temporarily install this pinion shaft so I can rotate that eccentric. It's a little bit too tight for me to turn it by hand, but I am going to have to remove the worm here because I can't get this knob on the end of the adjusting shaft. But pull this out, and when I put the knob on, that will adjust that that cam. So I just need to get it in the right spot so that it lines up with the bore on the other side. This shaft does fit in that bore nice and tightly. I do have to drive it the rest of the way here with some light taps with a brass drift, but it's not so tight that it can't be spun. Well, I'm not exactly sure what you might call this assembly here, but there is this thrust washer that goes on this stop or cover. This is what goes into that hole. This wasn't obvious when I first took it apart, but once I cleaned all the grease off, I noticed this thrust washer on the side. It is pinned in place. Put a little bit of grease on the surface before I insert it into that large bore. I want to thread this thing in until the face of that thrust washer that I just screwed on the end of it then comes in contact with the end of the worm drive. I'm probably going to need to adjust this later, but I believe this is used to take some of the backlash out of the engagement between the worm drive and the spindle. Then the set screw that I failed to see when I was disassembling it is then reinserted, and that captures this thing from being able to move once you set that that thrust or backlash adjustment. Well, this shaft here with the pinion on the end of it is what's used to tighten and unloosen the geared nut that's on that cammed eccentric shaft. With this thing all the way in and the teeth engaged, you can see here where I can loosen or tighten that nut that holds the shaft in place that engages the worm with the spindle. Come around to the other side of the machine here, and I can install the pinion shaft that's actually used to adjust that cam, which engages and disengages the worm to the spindle. So this inner knob is what's used to lock and unlock the cam. And then this outer knob is what's used to adjust that cam once it's unlocked. There's no avoiding it. It's time to get this spindle installed. This operation has me a little bit worried because it could all go downhill really fast. Well, before I install the spindle, I do want to grease the bearings. Yes, I am going to use grease here because I do believe that's what this thing was designed to use. I don't know the vintage of this particular dividing head, but the documentation that I can find on these Brown and Sharps shows oil cups, and this one definitely did not have oil cups on it. So I don't know if it's a different design. Maybe there's some characteristics of those that require the use of oil, but for this one, I'm going to use grease. So I'm going to put some grease around inside the bearing rollers. This race fits on here fairly loosely, so I should be able to get an adequate amount of grease inside those rollers. And while I'm at it, I might as well put some grease here on this worm gear. Before I try to insert the spindle here in this bore, I do want to make sure that this recess is cleaned up and there are no burrs. The bearing retainer plate that's on the front is an extremely tight fit, and I want to make sure that there's no burrs or anything that's going to prevent it from seating right, because that just means I'm going to have to take this thing apart again, and I want to avoid that. Hopefully, I've done everything I can do at this point. I'll try to get this spindle reinstalled. I know it's going to be a very tight fit, trying to get it slid into that bearing into the back. And I can kind of feel like it's at the point where it could start pressing in. I'll use a brass hammer here on the front of the spindle just to kind of start it. Well, this is kind of nerve-wracking because, you know, this plate, this escutcheon or whatever it is, just kind of floating there. Every time I move it, it kind of slides off. You know, should I really be, you know, hammering or even pressing on the nose of the spindle? Should I be pressing from this spindle plate? I kind of think maybe I could be because it looks like it presses more on the outer race. I found this piece of pipe in the scrap bin here, and it would have been almost perfect. It's not quite long enough, and the ID is just a little bit too narrow, but I found out later that this thing is rock hard, and I wasn't able to machine it to size. Well, this is making me very nervous. I really don't like doing this, using the hammer on the front of the spindle. I do see it making at least some progress, but it is pretty slow, and I just don't like using this percussion to get this thing on here. You know, the escutcheon is just kind of floating around. There's got to be, you know, a better way. I think I can maybe set this up in my arbor press. I do have the hydraulic press too, but I don't know that I want to use hydraulic power on this. I think I'd rather use the arbor press and be able to feel what's going on. I was able to rig this thing up here in the arbor press. It barely fits. I mean, barely fits with the piece of brass here on the nose of the spindle. And, you know, I'm just trying to just apply some nice even pressure. Nothing too much here. This escutcheon's kind of getting in the way, or at least I'm a little bit worried that it's going to end up getting pinched. But I am kind of laying, or should I say hanging on the bar. The handle for the arbor press, so I am putting a considerable amount of pressure on this. Every time I let off, I want to check the spindle, make sure it's still spinning. And so far, it seems to be going okay. But this escutcheon or retaining plate or whatever this is, just I feel like it's kind of in the way. Not so much that it's preventing me from being able to do this, but what I'm worried about is if I press this in too far and it's not lined up and it ends up pinching it, then I've got to press it back out. So I'm trying to avoid having to do rework here. I'll try something here. I've got some popsicle stir sticks here, a couple of them stacked up, putting underneath this plate. And what this is, I think, going to at least keep that plate lined up with the front of the spindle, at least for another 1/8 of an inch. And then I can remove them, because once the spindle's pressed in just a little bit further, I don't really need them anymore, at least not both of them. So we'll go down to one and press this in a little bit further, and then once it's down a little bit more, then I won't need them anymore. I do need to be cognizant of the mounting holes, because again, I don't want to press this thing in so far that I won't be able to line those up. Well, as I press this down more and more, these mounting screws for this escutcheon plate bearing retainer, I'm not sure what you're going to call this thing, I want to screw these in a little bit more each time, just to, I don't know, give me some kind of comfort that it's not misaligned. So as long as the heads of these screws are fitting into the counter bores, I can feel comfortable that this is in the right spot. I think that is pressed in all the way. If I compare this now to the photos and video that I had prior to disassembly, everything looks the same. Of course, it was a little dirtier, but the reveal that are showing in each of these different pieces looks the same as what it was before. So I feel pretty confident that this is pressed in as far as it needs to be. I brought this over to my welding table because I have it bolted down to it. I need it in a secure spot so I can install the take-up nut on the back of the spindle in order to set the bearing preload. First thing is this keyed washer that goes on over the back of the spindle, and then I can install the spindle nut. I'll reuse the same tool that I made to take this thing off in order to tighten it back down. I need to keep the spindle from turning so I can get this nut tightened. And the best way to do that really is with the combination of the spindle lock as well as the worm drive. So by engaging the worm with the worm gear, this will keep the spindle from moving and let me tighten this nut down. I'm going to disengage the cam now just so I can feel if there's any play in the spindle, if I've got the preload set reasonably well. I couldn't feel anything by moving the spindle by hand, so just to see how well we might have done here, I'm going to set up a test indicator on the back of the spindle and see if I can see any movement. Well, this isn't the most ideal setup, but I'm only getting maybe a half of a thousandth movement. I think that's more than good enough. I have it back over here on the bench so I can get this main indexing plate reinstalled on the front of the spindle. You can see how that plunger now fits into each of these 15-degree holes, and you'll see some numbers there stamped at the top that are for the divisions, right? So if you want to do 8 divisions, you just put the pin in all the holes that are marked with an 8. Well, one thing I didn't do yet was install this stop for this eccentric cam, and that's because you might recall when I disassembled this part of the dividing head that the screw that was holding this on was actually split in half, and I had to use a punch to get it out. I'm glad I was able to get it out because drilling it out would have sucked. But now I need a replacement, and there's no place local that sells anything like this. McMaster might have something, but the best I could come up with was this screw here that I was able to get from Ace Hardware. It's 1/4 20. It's the right size. The problem is the size of the head is much larger than the screw that came out of it. And I would like it to be the same. I think it needs to be flush in order for the cover that goes over top of this, and the gear that slides over the shaft. This needs to be flush, and right now it's not. So I'm going to take it over to the lathe, and I guess we're going to do a little bit of customization on this screw. I don't have a collet chuck for this lathe, so I mounted this in a 5C collet hex holder so I could grip it with my 6-jaw chuck, and it should be good enough here. I just need to turn down the face of this pretty much until the slot goes away, and I think once the slot goes away that the diameter of the head of the screw should be about right and match the old one. Well, that'll work, I think. Now I just need to take it over to the Bridgeport so I can cut a new slot in it. I have a slitting saw mounted in the spindle of the Bridgeport. No real precision needed here, so I'm just going to touch off on the top of what's remaining on that screw and then raise the knee up the appropriate amount that I calculated based on the diameter of their head and the thickness of this slitting saw, which I believe is 1/32 of an inch thick, which kind of thin, but should work. Running it slow and using a little bit of anchor loop here. Yeah, the slot is a little bit thin, but that's okay. The screwdriver fits in there, and that's a very nice fit. It sits just a little bit below the surface, which is perfect. Well, there's a collar that slides over the end of this shaft, and it's part of the mechanism for the indexing plates. And I want to make sure that there are no burrs on the end here, so I'm just using a light touch with a file. Maybe some emery cloth might have been a little bit better here, but regardless, I just want to make sure there are no burrs because it was a bit tough taking that collar off, and I suspect it's going to be a little bit of a challenge to get it back on. Well, I am certain that there is a burr on the front of this thing because even after polishing the inside of this collar, it just doesn't want to go on until it goes on. And then once it goes on, it slides on fairly nicely and rotates. I think there still might be some burrs on the inside of it or even some burrs on those slots. So let me try to get those cleaned up and try it again. Well, this little special screw here has got a little bit of tit on the end of it, and this acts as a key. So there's a slot that this thing fits into on this shaft, and that lets me rotate it left and right or forward and aft. And it also acts as a key for this indexing pin plate that slides into the bore of this shaft. So this shaft here has got a keyway in it, and that lines with the little tit on the end of that set screw. And this is just for locating that pin in the dividing plate that eventually gets attached to the side of this thing. Next to go on is this hub. On one end of the hub is a gear that is driven by that idler above it. And on the other end of the hub are some mounting locations for the dividing plate. Well, a couple of steps ago when I installed this collar and that shaft for the indexing pin, something didn't seem quite right. And that's because I forgot that there is a spring down in here that I never took out to clean. So let me get this out and get it cleaned up and reinstall it. The spring's all cleaned up. Let me reinstall it and that shaft. And yeah, that feels a little bit different. There wasn't getting any kind of spring back before. And I think it's because that spring was just so gummed up that it didn't really have any spring left in it. There was just too much garbage inside of there for it to operate cleanly. So with this back reinstalled, I'll install that set screw with the little tit on it, line it up with the keyway. We'll lock the collar in place and keep moving on with the next step. This gear cover had been painted, but the degreaser I use has a tendency to eat paint. And when this thing was left in the ultrasonic cleaner, most of the paint had come off. And quite frankly, I like the brass look better anyway. I thought about stripping the paint off of this gearbox cover and repainting it, but that would have meant that I would have to repaint some other things, and I didn't want to do that. And so I just kind of wanted to keep it its vintage look. So I just cleaned it up with some degreaser, not enough for it to eat the paint. And I'm just going to reassemble the parts. The parts have all been cleaned up with the ultrasonic degreaser, and they're just some helical gears and a straight tooth gear. It's pretty uncomplicated. I just picked one of the 3 dividing plates here to install on the end of the hub. And then the 2 sector arms will slide over that. And then there's a screw that's used to lock them together to hold their position. And this spring clip here is just to provide some tension on it so they don't move. So it adds a little bit of friction once you set them, that they'll stay in that position unless you physically move it. And this is a drive pin. This is used to spin that shaft, that internal shaft, which has the worm drive on the end of it. And of course, the worm drive is engaged with the worm gear on the spindle. So as this is driven, that drives the front of the spindle. And this is part of what drives it. This fits over top of that pin. These 2 screws on the side just clamp it. And as I turn this, of course, this then turns the spindle. And what turns that piece is this indexing handle. This is mounted in a slot and is held in place with a little tab and a screw. Well, there seems to be quite a bit of extra play here in this hub, and I think it has to do with that worm drive. So what I need to do is loosen the set screw here. I'm using one of the indexing holes to loosen the set screw, and then I'm going to tighten down this plug on the right side of the dividing head. So I'm putting more pressure essentially on the end of that worm drive, and that's taking up some of that play, and that certainly does feel a little bit tighter. So I think that's, yeah, maybe a little bit more of an adjustment, and then I can button this back up. Well, there are 6 zerks. I'm going to call them grease zerks because there's grease in them. And it says to use grease on the side of the dividing head. So we're going to call these grease zerks. There were 6 of them on this machine. And I really wanted to clean these up and use the originals. But it just, I could blow some compressed air through them and I would get some of the grease out. I even, went ahead and used some brake clean to clean the bulk of it out. But if I hook up a grease gun to it, I'm not getting grease through 3 of them. So I've decided to go ahead and replace them with some just generic grease zerks. I really would rather use the originals, but I have to use what works. And I think that completes the reassembly of the dividing head. And there were almost no leftover parts. No, I'm kidding. There were no leftover parts. Everything went back together fairly well. I did struggle a little bit with getting the spindle pressed into place. And, that indexing plunger took a lot more time than I anticipated it was going to take. But I think it looks great. I think it looks great compared to what it did before. This is a massive improvement. Not only does it look better, but I think it's functioning better. It's probably 20 pounds lighter now that all that grease is out of the inside of it. And now I'm on to the next task, which is how am I going to figure out how to get this servo mounted to that input shaft so I can drive it with the Dr. DRO. Well, I picked up a couple of pulleys here, one for the motor and one for the back of the dividing head. So the next step I think is going to be to devise some sort of a mount where I can mount the servo on the back of the dividing head so it maintains as one unit, and figure out some calculations on how fast it needs to spin, etc. But I think I've got a plan anyway. I've got some stuff drawn up. Now it's just time to execute it. So look for that video sometime in the future. Well, that's it for this one. I hope you enjoyed it. If you learned something, let me know, because I learned a lot by taking this thing apart and putting it back together. I now have an appreciation of how it functions, and I'm really looking forward to being able to put it to use. If you're a subscriber to the channel, thank you very much. Your viewership really is appreciated. But if you're not a subscriber, hit that button, hit that bell icon. I find that about 75% of the people that watch my videos aren't subscribers to my channel. It costs you nothing to do so, and it gives you a notification of when I drop another video. I'd appreciate it if you'd come back and check out my other videos and what I have coming up in the future. And a special shout out to those that choose to support the channel either through Patreon, channel memberships, or PayPal. Your contributions to the channel is greatly appreciated. Thanks for watching, and we'll see you on the next one.